This video looks at matrix multiplication. Now, matrices can only be multiplied if they are conformable. Now, A and B are conformable only if the number of columns of A equals the number of rows of B. Now, the matrices then must be multiplied in the stated order, which is A times B. You can't go B times A. Now, if A is the order M times N and B is the order N times P, then you can see we can do A times B because we have the N in the middle. So those N's are the same. What we'll end up with when we multiply is an M by P matrix. Okay, so if I have A being a 2 by 3 matrix and B is a 3 by 4 matrix, then I can do A times B because that will be a 2 by 3 times by a 3 by 4. And you see these numbers in the middle are the same. So it's conformable. They're conformable matrices. What we'll end up with is a 2 by 4 matrix. So our result will be 2 by 4. So that would be A, B. If I did BA, which is B times A, I'd have a 3 by 4 matrix times by a 2 by 3. These middle numbers here aren't the same. So my number of columns of B is not the same as my number of rows of A. So they're not conformable. Okay, so you can't do it. Now, when multiplying, the biggest rule to remember is across the row and down the column. That's key when you're multiplying. So as you can see in this example here that I've color coded, we go across the row and down the column. We do that, we use the same row for as many columns as there are, and you'll see that in further examples. But here, so we're going across the row, 2 times 3 down the column, plus 1 times 7 plus 5 times 10. Then we move on to the next row, 3 times 3 plus 4 times 7 plus 6 times 10. Another thing you'll notice is that these second numbers are always the same. So that can help you get through it quicker. Then do the sum, 6 times 3 plus 1 times 7 plus 5 times 10. So 6 plus 7 plus 50 is 63. For your next one, 3 times 3 is 9. 9 plus 28 plus 60 is 97. So you can see we've ended up with a 2 by 1 matrix because your 3's were the same. Your number of columns of your first matrix was the same as the number of rows of your second. And you can see why these need to be the same because you're going across the row and down the column. So you need the same number of columns to be able to go down the rows. Otherwise, it won't work. And your result is that 2 by 1. Okay, so now let's look at our laws of matrix multiplication. As we've just learnt, matrices need to be conformable. So provided A, B, and C are M by M matrices, meaning they're square and the same, it can be proved that AB times by C is the same as A times BC. Now note the order matters. I've got A, B, C, A, B, C. I'm not changing the order, and that's really important. So I can multiply my A and B and then multiply the answer to that by C, or I can multiply B by C and then multiply the A by that answer. But the A comes first. The order has to matter. In my distributive law, A bracket B plus C is the same as AB plus AC. Remember that A is first. the order matters. In this case, you would be better off or quicker doing that B plus C first. But remember, it's A times B plus C, not B plus C times A. That order matters. In the next one, your B plus C times A is the same as BA plus CA. Again, see that order. This A is second because it's second with the BA plus CA. Okay? So what I'm trying to say is that B plus C times A is not the same as A, B plus C. Okay? Final one, and I've noticed I've got little b's instead of capital B's, so I'll change that. Okay, so here we're multiplying by a scalar. So if I have matrix A times by the scalar times by B, that's the same as if I bring the scalar out the front. So I can do A times B and then multiply that by the scalar. Similarly, I can do the A times by the scalar and then multiply by the B. Note the order AB, AB, AB. It's always the same. Also note that A times by A is the same as A squared and A times A is A cubed. Now, the reason why I'm saying that order matters is that matrix multiplication is generally not commutative. Now, the reason why I'm saying that order matters is that matrix multiplication is generally not commutative. Okay, meaning AB does not equal BA. So you have to get that order right. One good example of the AB not equaling BA is if I have A as being a 2 by 3 matrix and B being a 3 by 4 matrix, I can do A times by B. That works because it'll be a 2 by 3 times by a 3 by 4. Our number of columns of A equals our number of rows of B, and we'll end up with a 2 by 4. If I did it the opposite way, B times A, it'd be 3 times 4 times by a 2 by 3. Our middle numbers aren't the same. So you can't do this. The next example will always also show you about AB not equaling BA, and not just because they're not conformable. Okay, A times by B, 1, 3, 4, 2, times by B, 5, 1, 6, 3. You're going across the row, down the column. Then you'll go across the row again and down the next column. You've got a 2 by 2 times by a 2 by 2. So your middle numbers are the same, so it works out, and you're going to end up with a 2 by 2. It's always good to know what you're going to end up with, so you can pick up any silly mistakes you're going to make. So 1 times 5 plus 3 times 6. Move across. 1 times 1 plus 3 times 3. Next, 4 times 5. So we're going now across this row and then down each column. So 4 times 5 plus 2 times 6. Then 4 times 1 plus 2 times 3. So look at that little trick that I was telling you. These second numbers will always be the same. And then going across, your first numbers will be the same. So let's evaluate that. 5 plus 18 is 23. 1 plus 9 is 10. 20 plus 12 is 32. 4 plus 6 is 10. Now let's do it the other way. Pause the video and have a go yourself. So now we're doing B times A. Okay, cross the row down the column. So I got 5 times 1 plus 1 times 4. Then I move across to the next column. 5 times 3 plus 1 times 2. Next, 6 times 1 plus 3 times 4. And 6 times 3 plus 3 times 2. Evaluate those. 5 plus 4 is 9. 15 plus 2 is 17. 6 plus 12 is 18. 18 plus 6 is 24. And you'll note these two here are not the same. AB does not equal BA. Check the answers on the calculator. Make sure you know how to do matrices on your calculator. Let's look at another example. So here I've got two matrices A and B. Part A says state the order of the two matrices. So A is a 2 by 3 and B is a 3 by 2. Part B, state which products exist. So if I went A, B, that'd be a 2 by 3 times by a 3 by 2. These numbers are matching, so yes. Part 2, B times A, so that'll be a 3 times by 2 times by a 2 by 3. Two middle numbers match, so yes. Part C, state the order for the products that exist. So for A, B, we're looking at the outer two numbers, so it'll be a 2 by 2. And for BA, you're looking at the outer numbers, so it'll be a 3 by 3. Okay, part D, calculate the products that exist. So part D, if I do AB first, that's going to equal 1, 2, 3, 4, 5, 6 times by 2, 0, 5, negative 1, 4, 3. Remember, across the row, down the column, and we know we're looking for a 2 by 2. So 1 times 2 plus 2 times 0 plus 3 times 5. Move across to your next column. So 1 times negative 1 plus 2 times 4 plus 3 times 3. Next, 4 times 2 plus 5 times 0 plus 6 times 5. Then 4 times negative 1 plus 5 times 4 plus 6 times 3. Evaluate that. So you've got 2 plus 15 is 17. Negative 1 plus 8 is 7. 7 plus 9 is 16. 8 plus 30 is 38. Negative 4 plus 20 is 16. 16 plus 18 is 34. Now let's do BA. I'm going to go across because I'm going to run out of room. So now I've got 2, 0, 5, 1, 4, 3 times by 1, 2, 3, 4, 5, 6. So 2 times 1 plus 1 times 4 move across. So you're going across the row and then down each column. So we've got 2 times 2 plus 1 times 5. Then we've got 2 times 3 plus 1 times 6. And my bracket is not big enough because I need to have 3 rows in this. I should have gone back to the knowing that I'm going to end up with a 3 by 3. So 0 times 1 plus 4 times 4, 0 times 2 plus 4 times 5, then 0 times 3 plus 4 times 6, final 5 times 1 plus 3 times 4, 5 times 2 plus 3 times 5, 5 times 3 plus 3 times 6. So now evaluating that, 2 plus 4 is 6, 4 plus 5 is 9, 6 plus 6 is 12. Move on to the next one. 0 plus 16 is 16. Then we have 0 plus 20 is 20. 0 plus 24 is 24. And our last row, 5 plus 12. I might make that bracket bigger. So 5 plus 12 is 17. 10 plus 15 is 25. And 15 plus 9 is 24. One more example that's a practical one. This one says matrix A shows the number of car models A and B bought by 4 car dealers A, B, C, D. Matrix Y shows the cost in dollars of cars A and B. Find X, Y and explain what it represents. So X, Y is going to be 31221411 times by 26,000 and 32,000. So just so I know what I'm going to end up with, this is a 4 by 2, this is a 2 by 1, so I'm going to end up with a 4 by 1. So across the row, down the column. So I've got 3 times 26,000 plus 1 times 32,000. Then I've got 2 times 26,000 plus 2 times 32,000. So hopefully when you're going through this process, it's making you realize what you're actually working out here. Because remember, each row of XY is a car dealer. And I'm multiplying by the price of the cars. So what you're doing is you're working out how much each dealer spent. So evaluating that, first one will be 110,000. Next will be 116,000. Then we have 154,000. And finally 58,000. So these amounts represent what each dealer spent. So dealer A spent 110,000. Dealer B spent 116,000. Dealer C spent 154,000. And dealer D spent 58,000. I would envisage that this would be quicker doing by hand than on your calculator because you do need it enter your matrices into your calculator. Check it on your calculator and see. Just give it a go. What is quicker, by hand or by calculator?